All right, so today we're going to factor polynomials. So today we're going to do all of the types of factoring, and then tomorrow you'll just practice where you have to figure out which one you're doing. And then we'll also talk about some other problems that are a little harder than these. Okay, so basic factoring polynomials. You have factoring out a GCF. So if you have a problem like number 1, you're wanting to know what do all 3 of these have in common. That's the GCF, the greatest common factor. So 9, 18, and 27 are all divisible by 9. Everybody has an x, and the smallest amount of x's would be 2. So the GCF is 9x squared, because all 3 of those terms can be divided by 9x squared, which is what you're really doing when you're factoring, is you're trying to tell me what 2 things multiplied to get the original problem. So to get what I multiply 9x squared by, I have to think about 9x to the 4th divided by 9x squared, and that would be x squared. You can also think, what do I multiply 9x squared by to get to the 9x to the 4th? And again, that's going to be x squared. All right, so our next term, this negative 18x to the 3rd. We do negative 18 divided by 9, that's 2, negative 2. We do x to the 3rd divided by x, that's x. We do 27 divided by 9, that's 3. And x squared divided by x squared is 1, so we don't have any x's. All right, so at this point, you have finished factoring for today. Tomorrow, we're going to talk about factor completely, where you have to think about take out a GCF and then kind of factor some more. For today, you're going to have a section that says factor out the GCF, a section that says factor the trinomial. So today, it's just straightforward, simple, factor one time, you're done. Okay, so number 2 is also a factor out the GCF problem, and it's also missed a piece. Let's see, this needs to be a plus sign in between them. Okay, so if you look at what we have, you have 2 terms. You have 2 terms. So this term and this term both contain that 2x plus 5. So we take out a 2x plus 5 as the GCF. So if I take this term and I divide 2x plus 5 out, those cancel, and I'm left with x squared. If I take this term, that 2x plus 5 cancels, and I'm left with 17. And that's all there is to that. All right, so GCF, you have these nice simple ones, and then you have these that aren't as pretty looking, but they're really not any more difficult. All right, factor by grouping is what you're going to do when there are 4 terms. So what you're going to do there is take out a GCF twice and then do it again. So actually 3 times. So factor by grouping, you're going to take the first 2 terms and group those. Then you're going to take the second 2 terms and group those. So that's called grouping. All right, so for the first 2 terms, you're just going to take out a GCF for just those 2 terms. So these 2 have an x squared in common, because that's the smallest amount of x's. And the numbers don't have anything in common because this one is just a 1. All right, so if I divide that x squared, I have x. If I divide by x squared here, I have minus 2. All right, so same thing with the back 2. What do these 2 terms have in common? Well, 5 and 10 can both be divided by 5. Whatever this sign is going to go here. There's not an x in both of them, so you can't take x out as part of your GCF. So if I do 5x divided by 5, that's x. If I do negative 10 divided by 5, that's negative 2. All right, so now this problem kind of looks like what we had on number 2, because you have these 2 terms, and they both share this parenthesis. So to factor, you pull out that GCF of the parenthesis. Forgot to pick my pencil up, and then it didn't work. And then when you divide this off, you're left with x squared. When you divide it off here, you're left with plus 5. And you're done. All right, so number 4, group the first 2, and let's take out a GCF. So 4 and 24 are both divisible by 4, and the smallest amount of x's is 2. All right, so if I take 4x to the 3rd and divide by 4x squared, the 4's cancel. X to the 3rd divided by x squared is x. 24 divided by 4 is 6, and the x squared is canceled. All right, so then we look at the back two terms. So we have negative 2 and negative 12, so we're going to take out negative 2. If I take negative 2 out, divide by negative 2, this is going to be positive x, because the negative 2's cancel, and I'm left with that x. And then here, negative 12 divided by negative 2 is positive 6. All right, so at this point, you see that your two terms have that matching parenthesis of x plus 6. And then when you divide that off, you have 4x squared and minus 2. All right, now technically, this would factor again. You could take a 2 out. But again, for today, we're just going to do straightforward factoring. You don't have to factor again. So you factor by grouping, you're done. All right, next is factoring trinomial. So trinomial means 3 terms. When you factor a trinomial, there have probably been several different methods that people use. They all boil down to guess and check. So I'm just doing the straightforward guess and check. If you are taught some kind of box method, I'm okay with that. If you were taught some kind of crisscrossing method, I'm okay with that as long as you get the 2 parentheses. All right, so to factor a trinomial, these first 2 numbers, this number and this number, have to multiply to get this number. So to get a 3x squared, I can do a 3x times an x. Don't have a clue what happened. Sorry. All right, your back 2 numbers, I was really just trying to push that, and I think I hit something else. I don't know. All right, so the back 2 numbers have to multiply to get that back number. So to get a negative 2, you need a 2 and a 1, somebody positive, somebody negative. All right, so at this point, we have made an educated guess to make sure that we multiply to get that. And we've made an educated guess to make sure that we multiply to get that. Because if I'm going to take these 2 things and try to get this back, that's going to be what we did in the previous section. So to check, I just have to make sure that it's going to work. I know this gives me 3x, and I know this gives me negative 2. So the check part comes into, do you know whether you're getting the right middle term? So we check by doing the outside and the inside. That's going to be negative 6 and positive 1 the way I have it. If I add those together, that's not going to give me negative 1. So something is not okay about what I have. So let's see if we switch the 2 and the 1, if that fixes our problem. All right, so we said switch 2 and 1, so we'll put a positive 2 here and a negative 1 there. Now we'll check. Here we're going to get a negative 3x. Here we're going to get a positive 2x. If I add those, I get negative x, which is what I wanted. So I am done. I factored correctly. This is my answer. If I multiply those 2 parentheses together, I'm going to get that original problem. All right, so number 6. We are trying to come up with the 2 little binomials that multiply to get that trinomial. All right, so again, you make a prediction what you think you need in the front. Now you have 2 choices here, 4 times 1 or 2 times 2. Which one do you think is going to work? Most people are going to choose 2 times 2, so we'll go that route and see what happens. Then we need to know what multiplies to get, I meant to change that color and it didn't happen. What multiplies to get 15? So again, you have 2 choices, 1 times 15 or 3 times 5. And again, you just pick one. So let's say 3 times 5. You're multiplying to get a positive, and you're going to want to add to get a positive. So we know these signs are both positive. All right, so now are we going to get the right thing in the middle? All right, well, let's see how we did. To get this number in the middle, we are going to multiply the outsides, multiply the insides, and if we add those together, do we get the 16? We do. So we got lucky. We got it right the first time. This is the answer. All right, so it's called guess and check because you make educated guesses about your numbers and you check to make sure that that middle term is going to work out correctly. So should you use pen when you're factoring? Probably not, because you're usually going to have to erase. All right, number 7. Let's see here. We have a trinomial, so we should try to get to binomials. To get x squared, you only have one choice, x times x. To get 14, you can do 1 and 14 or 7 and 2. Since I'm going for a 9, I think 7 and 2 sounds good. I want to multiply to get a positive, so these have to have the same sign. But I want to add to get a negative. That tells me that they have to have negatives. All right, so again, I know x times x gives me x squared. I know negative 7 times negative 2 gives me positive 14. I am checking to see if I can get this negative 9 when I do the outside and the inside. And the answer is yes, that is correct. So box it and move on. All right, so I think you might be at a point now where you can pause the video and try this one and see how you do. All right, so to get 9x squared, let's see, do we want to use 1 times 9 or 3 times 3? Most people are going to choose 3 and 3. I really think it's supposed to be 1 and 9, but most people are going to go with 3 and 3, and I want you to understand that you're not always going to have the right answer first, so I don't want to pick the right thing to start with. All right, so now we got to multiply to get negative 4, so you need a positive and a negative, and one of them's a 4, one of them's a 1. All right, so my goal is to have 5 in the middle. That is not the color I'm intended to use. 5 in the middle. All right, so this gives me negative 3. This gives me 12. That is not going to get me 5. All right, so I know that that's not a good choice. All right, so my choice here, when I decide I need to change my numbers because they don't work, is do I want to switch to 1 and 9? Do I want to switch to 2 and 2? So you can think through things. If I do 2 and 2, that's going to give me 3 times 2 is 6. 3 times 2 is 6. That's not going to get me 5 either. So I'm thinking that switching these guys to 9 and 1 is going to be the right choice. So I need my pens. Okay, so I think 9 here, because it'll multiply by the 1, and 1 here, because it'll multiply by the 4, should get me my 5. All right, so checking on the middle term. This is negative 9, this is positive 4. That's going to give me negative 5, and I want positive 5. So if I change this, that just means these guys have to change. So we're going to make this a plus, and we're going to make this a minus, and everything works out, and we are finished. All right, these next two are still the same thing. So again, you can pause and see how you do. All right, 2 trinomials. So we're going to work it the same way. We're working towards a 64. The first thing that comes to mind for 64 is 8 times 8. All right, and then we're trying to get a 1. Your only choice there is 1 and 1. Multiply to get a positive means the signs are the same. And this guy tells you they should be negative. All right, checking to see if the middle works out. This is negative 8x. This is negative 8x. So if I combine those, it's negative 16x, which is what I wanted. All right, number 10. All right, so this one looks a little scarier, but it's really not, because you see how this is an x squared, this is a y squared? Well, this has an x and a y, so I think it's going to work out just fine. All right, so to get our 6x squared, you have choices of 3 times 2 or 1 times 6. So let's go with 3x and 2x to get 6x squared. All right, to get 5, your only choice is 1 times 5, and they both need a y. So you can do 1y and 5y. Somebody's got to be negative, somebody's got to be positive. All right, so then checking to see if we're going to get negative 7. Let's see, we got 15 xy and negative 2xy. That's going to give me 13, and I need negative 7. So if I change the signs, I'm still going to get 13. It'll just be negative 13. So let's see if maybe I switch and put the 5 here. I really thought I just changed that color, but apparently I didn't. I'll put the 5 here, and we will make this one the 1. And let's see what that does to our numbers. All right, so that's going to give us 3xy. And this is going to give us negative 10xy. That does give me my negative 7. So that's what I want to use. All right, I'm happy to answer questions that you have about factoring, but if you look on Google Classroom under resources, there's a thing there with links to several videos on factoring that is also going to give you some more examples. Okay, so before we are done for the day, we have 2 special cases to talk about. You can factor the difference of squares, and you can factor a sum or difference of cubes. So with squares, it has to be a difference of squares. You cannot factor a sum of squares. And they're always going to factor the same way. It follows a simple little pattern. You need 2 parentheses. You're going to take the square root of that first term. So x and x gives you x squared. And you're going to take the square root of this back term that do 1 positive, 1 negative. So 8 times 8 is 64. And that always works because that always gives you conjugates, which means that this negative 8x and positive 8x, those outside-inside terms are always going to be 0 because that always happens with conjugates. All right, so number 12, going through that pattern again, 2 parentheses, 1 add, 1 subtract. The front numbers are the square root of the first term. So in this case, it would be 6x. The back numbers are the square root of the second term. So in this case, 7y. So you got 6x plus 7y, 6x minus 7y. All right, sum and difference of cubes. Cubes behave differently, so you can do sum or difference because you can do a negative 3 times or a positive 3 times, and you get a positive 1 time and negative the other. With squares, when you multiply 2 things times each other, it always works out to be a positive. All right, so for sum or difference of cubes, it's a pattern. I just need you to listen to what I'm saying. If you look in your book, they have it, but it's like with A's and B's, and it's kind of abstract, and it really doesn't help people remember, most people. If you think it'll help you, look it up in your book. But it's really just a matter of can you memorize a simple pattern. So for sum or difference of cubes, if you see that it's things that are perfect cubes, then you're going to get a binomial and a trinomial. Instead of 2 binomials, like with the sum, like with the difference of squares, you're going to get a binomial and a trinomial. All right, so the binomial is always the cube root and the cube root. All right, so if you think about this, this is x to the third. This is 4 to the third. Okay, that's what 64 is, 4 to the third. So all you did were their cube roots. Okay, I probably should have done this in purple. That's horrible. Why did I do that? I thought I could trace myself, but obviously I cannot. Okay. All right, so once you have this first parenthesis, the little binomial, which is just the cube roots and the matching sign, then from there, you're going to square the front, and I'm just going to write all of these in blue because there's really no color coding that's going to help. Listen to what I'm saying. You take this guy and square it. Multiply these together and change the sign. And then you square this one. Always follows the same pattern. Alright, so let's try another one. You need a short and a long, a binomial and a trinomial. Alright, cube root of this, so 3x. Then you want the cube root of this, so positive 5. Alright, now we use this guy. And we're going to square the first, multiply them together, change the sign, square the back. That's a plus sign, not minus and negative. Sometimes I try to fix things and I make them worse apparently. Alright, I think that's all. We'll change the slide and see. Yes, it is. Alright, so again, you're going to have a section that says factor this way, a section that says factor this way. So just look at those examples. If you need more examples, then find the videos that are linked under resources. If you need help from me, email me and I'll be happy to help.